So welcome, everybody. I'm going to be talking about building a scalable JavaScript application architecture. So a little bit about me before I get started. I worked at Yahoo for a while, several years, and was a tech lead there on several projects. A lot of the things I'm going to be talking about today were really kind of discovered as I was working at Yahoo and found to work really well on large-scale applications. I'm the co-creator of CSS Lint, which is a CSS code quality tool. Go check out at csslint.net. And I'm also a contributor to YUI, as well as the author of several books. And if you wish to follow me on the Twitter, I am Slicknet. Okay, so the reason why we're talking about this today is because there's been a lot of discussion about this thing called single-page apps. Right? So these are the Ajax applications today where you just load up one page and you basically leave that page there for the entire time. You don't ever need to unload it because everything happens within the context of that page. There's been a lot of discussion about this lately, and then a lot of discussion about the model view controller pattern, or MVC for short. Backbone has really kind of made that more popular discussion recently. So what I'm going to be talking about, just to set it in the context of this, is really more about the controller side of things. It's how you determine behavior on the page. And the model and the view you can do in any number of ways. That's why I don't want to cover it here. But just keep this in mind as we're going through. And the reason why I like focusing on the controller is that it's really good for both single-page apps and for multi-page apps. So if you have a single-page app with a bunch of functionality on it, with a lot of things that are changing, it will be good for that. But also if you have a multi-page app, so an app that has a bunch of pages that maybe shares some functionality across them, will also be very helpful for that. And so what I'm really talking about here is building an application framework. And I'm not talking about a specific application framework. I'm not here to promote anything in particular other than this sort of architectural approach. But I want you to build an application framework that works for you and your organization. Now, an application framework I like to think of as a playground for your code. Apps do a ton of things that are kind of related, but not always entirely related. And an application framework helps to tie all of that together in some sort of meaningful way. So isn't that what JavaScript libraries do? A lot of times when I start out, people just say, well, I'm using jQuery, right? That's an application framework. Well, no, it's not. A JavaScript library is very different. A JavaScript library provides you with the tools to do a lot of different things. You could build an application framework on top of it. You could also just hack together a page really quickly. There's a number of things that you can do, just like having a toolbox. It really depends on how you use what you have there. So I'm going to be referencing this architecture diagram throughout, and this is just a very gentle introduction to it. So you have your base library, your JavaScript library, which is jQuery, YUI, Dojo, whatever you like the best. And the application framework, the application core, is built on top of that. So they're really two separate and very distinct layers. Okay, so to take a little step back, I want to talk to you about a thing they call module theory. So if you were to look up module in a dictionary, you'd find a bunch of descriptions, definitions there. I'm not expecting you to read all of these, actually. But the one that I found most interesting when I went to look this up was this one. An independently operable unit that is part of the total structure of a space vehicle. Right? Kind of awesome. It's okay to laugh at this stuff, by the way. You don't have to feel like it would be. Okay, why am I going to talk about space stuff now? Yes, I am. So we have this thing called the International Space Station, which is this mammoth thing that is floating in the sky around Earth, just in orbit, and it's gigantic. You think about, man, how did they ever build that thing? Right? Because it's huge, and you have to figure, if you built this huge thing on Earth and then tried to get it up into space, you'd have all kinds of trouble. Right? So what they actually did was separated it out into all of these little modules. And this was really cool, because that meant they could build small pieces independent of one another, get the small pieces up into outer space, and then combine them there. A lot safer and a lot easier than trying to build the entire thing on Earth and get it up into outer space. The really cool thing about this is that because these were small pieces and they were defined by clear interfaces, the people who were working on these didn't even have to talk to one another, really. They just went on the specs that they had, they built their thing, and this is why they were able to split out different pieces of the space station to different countries. And so all of these are color-coded by countries. Obviously, the US did a lot, Russia did a lot. But by having well-known interfaces, everybody could just go and do their job, and when they got everything up into space, things just worked. Okay, I'm sure that they didn't just work, but they probably mostly worked. And so what can we learn about that for web applications? Well, I'll give you this definition of a web application module. An independent unit of functionality that's part of the total structure of a web application. Blah, what does that mean? Okay, well, if you look at a page like My Yahoo, how many people have a My Yahoo page, just out of curiosity? Oh, there are a few of you out there. Excellent. So this concept is probably pretty familiar to you. You have a bunch of modules on the page, and it's really obvious what those modules are, right? They're these things here. They're little pieces of the page that are doing something very specific. And on My Yahoo, you can actually rearrange these and pick and choose what you want to have on there. Basically, create your own customized page. But you can also start looking at other parts of the page and splitting them up into modules as well. Like maybe up there is a module, maybe there, maybe that, maybe that. I'm not saying this is actually the way that it's done, just that it's a way that it could be done. Looking at the page as a bunch of independent pieces of functionality that could be developed and maintained separately. So each web application module consists of its own HTML, its own CSS, and its own JavaScript. Now, I'm going to be focusing on the JavaScript part of it today, but just keep this in mind as we're going through that really you're talking about an entirely little page actually within another page. Now, any single module should be able to live on its own. So what does live on its own mean? It means that you should be able to create a page that you load just that module on, and it works exactly the same as if it was on the larger page with a bunch of other modules. And why is that important? Well, it's important because, one, you can make sure that your stuff works without depending on everybody else. And two, once it's combined with a bunch of other modules, you can be sure that if it worked on a standalone page and then it doesn't work when it's combined with other modules, there's some weird interaction going on there that you need to investigate. This entire architecture is about a concept called loose coupling. Because as you build up your web application, you will have a ton of modules. And the last thing that you want to have happen is have this guy over here is working on his module and checks in some change, and then the three guys over here who are all working on their modules all have to go and make a change because of that. Right? That's tightly coupled. A change over there affects something over there. And that's exactly what you don't want when you're building up a large web application. What you want is to be able to make a change on your own, on your module, and know that it's just going to work and it's not affecting anybody else. So how do you do that? Well, each module has its own sandbox, which basically limits what the module can do. And I'm sure at some point I'll end up with a question of, well, how do you do that in JavaScript? Like, there's so much that's shared and so on. Well, I just do it by convention. Is that if you get everybody on a team agreeing that they're going to be writing code in the same way, that's usually good enough. If you want, you can add some code validation tools on top of it to help a little bit. But convention is usually the way to go when JavaScript is concerned. So back to our architecture diagram here. We had the base library and the application core. You're going to throw on top of it this sandbox. And the sandbox basically is a very thin layer. It doesn't have any functionality on its own. But what it does is provides an interface into the application core functionality. And then when you have multiple modules, they sort of float around the sandbox interface because that's what allows them to interact with the world. So these are the four things that we're going to be talking about, basically modules, the sandbox, the application core, and the base library. We'll start with the modules. The modules have very limited knowledge of what's going on. Right? They don't know about each other, and they only know that the sandbox exists and that they can use it. and that's pretty much it. And this is very important. This is where I see a lot of application frameworks kind of fall flat, is that when modules know about one another directly, you've tightly coupled them together, and that means anytime you change one, you have to probably change the other and at least test the other. And that's really bad when you're on a team that's scaling out and an application that's scaling out. Once something is done, it needs to be done. So this is a little bit of pseudocode of what it might look like to register a module. And I call this pseudocode because this doesn't actually come from any library. I don't have this to share afterwards. Again, I'm not here to promote any library, but I want you to be able to go out and create this on your own. So here, I'm basically just saying register a module with a given name. And the function that's being passed in is a function that creates an object that's returned. The function is getting a sandbox object passed in so that that can be used in the process of creating the object. But that's it. There's not anything else that this module has access to. So which parts of this application actually know about the web application being built? None of them do. It's not important. You should think about these as pieces of a puzzle. Right? Puzzle pieces themselves have no idea what the picture is when it's put together. Right? And it doesn't really matter, because as long as the puzzle piece is in the right shape, then it's doing its job. And the parts of this architecture are the same way, is that every little piece of this is just a puzzle piece. Just a puzzle piece. And so what is a module's job? Well, if you're the weather module, it's your job to tell people about the weather. And if you're the stocks module, it's your job to tell people about the stock market. Each module's job is just simply to create a meaningful user experience. Right? And that's the overall web application's job. But you want each part of that application to be doing that as well for whatever it's designed to do. Weather should be really awesome at telling you about weather. Stocks should be really awesome at telling you about stocks. If you go into a mail application, the mail view should be really awesome at telling you about your mail. And so the web application is created as a result of all of the parts doing their job, right? All of the puzzle pieces coming together to create the complete picture. No Hello Kitty fans? It's usually good for at least a chuckle. Now, this doesn't mean that modules can do whatever they want. They have to follow some rules, because like little kids, they can get into trouble if you don't give them some rules to live by. And so what are the module rules? Well, one is hands to yourself. Right? Only call your own methods or those on the sandbox. Don't access DOM elements out of your box. So like I showed earlier, each of those modules actually has its own box that it's dealing with. Right? And that's all that it should care about. It shouldn't need to worry about anything that's going on outside of that. There shouldn't be a reason to go up to body or HTML and start doing stuff at that level. Right? Keep your hands to yourself. Only access the DOM elements that the module needs to. Don't access non-native global objects. So non-native basically means anything other than date, object, array. You wouldn't want to touch window directly. You wouldn't want to touch document directly. You want to have those abstracted out. Ask, don't take. So if you need something else that you can't do with the first bullet, then you need to ask the sandbox for permission to do it. Don't leave your toys around. So don't create global objects. That just creates a mess for everybody. And don't talk to strangers. So don't directly reference other modules. And we want to keep this as loosely coupled as possible. And I know a lot of times when I talk about this to developers, immediately they're like, oh, this seems like way too restrictive. I can't really do my job with all of these rules. And that's actually not the case. So a well-designed application framework basically allows everybody to do the things that they need to do, but perhaps not what they want to do. And so it's very important for maintainability going forward that the modules stay within their own sandboxes. And there will be a lot of hand-wringing and a lot of angry people initially. I know this from experience. But down the line, when it makes things easier to maintain, easier to change, and you are sure that you can make a change in one module without affecting other ones, that's when people start to see the value. Okay, so that was modules. I'm going to talk a little bit more about the sandbox now. So the sandbox, up at the top of the architecture diagram, Basically, its only job is to ensure a consistent interface. Right? It defines the way that the modules interact with the world. And that's important because there's actually a lot going on here. But if the modules only need to deal with the sandbox, then it really doesn't matter what goes on at any other place in the application stack, as long as that remains there and as long as the interface remains consistent. And modules only know about the sandbox. So again, they don't know about each other, and they don't know about anything that exists below that in the architecture diagram. A sandbox also acts like a bit of a security guard. So again, a lot of this is by convention rather than by forcing it. But the sandbox's job really is to say, like, yes, you're allowed to do this, go ahead, or no, you're not allowed to do that, try to find it some other way. So again, silly pseudocode. In this module, it's asking the sandbox if it has cheeseburger. And if so, throws up an alert. Not very exciting, but that's probably why you didn't laugh. Yes, okay. So what are the sandbox jobs? One is consistency, really, just to make sure that the API there doesn't change. Right? The modules need to rely on that in order to do their job. The second, again, is security. So to make sure that the module can't get access to the things that it shouldn't have access to. Communication is one that we haven't actually talked about, but sandboxes are the way that modules can communicate with one another. And we'll dig into that a little bit more. Take the time to design the correct sandbox interface. Really think about it up front. Figure out what are the top 5 things that every module is going to need to do, and make sure that it can do it that way. Some examples of that are, if you need to be able to read configuration information, or need to interact with the DOM in a specific way. These are all things that should be just baked into your sandbox from the start. So next up, we're going to talk about the application core. So the core is really important, but all it does is manage modules. It doesn't actually know anything about the application as a whole. It's just another piece of the overall puzzle. And I sometimes refer to this as well as an application controller, just to put it in more of the MVC terminology. But it's basically the same thing. It is the object that is responsible for running the page. And it runs the page only by virtue of running the modules. That's it. So the application core is responsible for the life cycle of each of the modules. Basically tells the module when to start and when to stop. So when the page loads up, it's going to tell everything to start. When the page unloads, it's going to tell everything to stop. It may do some of that in between, too, if you dynamically load modules onto the page. But lifecycle management is very important. It's very rare that you just want to start something and then never do anything with it again. You almost always want to have the ability to stop it at some later point. So again, with some pseudocode, your core might start to look like something like this, which has a register method, which I actually showed a little bit earlier, that just says, what's the module ID, and then what's the function to call when I want to create that module. And then a start method and a stop method that just allows you to start and stop a particular module. Another important part of this that you'll note is that the module object itself is not really passed around. So start and stop just accept a module ID and not the object itself. And that's important also from the quote-unquote security aspect of the architecture to make sure that modules don't accidentally get access to other module objects. You want to try to hide those as much as possible. And so you may also want to have a start all and a stop all. Just start everything that's registered, stop everything that's registered. And for page load and page unload, that might also be useful. And then when you're going to build your web application and start it up, you end up with something that looks like this. Right? A bunch of modules that are being registered, and then the application core starting them all up. And each of these modules may be in a separate JavaScript file. You may throw them into the body of the page. It really doesn't matter. It's just that this pattern will end up being followed. And the application core manages communication between modules. So even though I was saying modules shouldn't know about one another, they do need to be able to communicate with one another, absolutely. So why? Well, I'm going to go back to my friend old Twitter. That's just because this example works a lot better with old Twitter than new Twitter. So if you look at this, you can actually separate it out into a bunch of modules as well. So maybe you have one there, and you have one there where you post your status, and you have the timeline, you have a little bit there, and a little bit there, and you basically end up with a bunch of these. Let's see, is there one more? Yeah. Okay, so you have all of these modules that are on your page, but you know that these actually need to interact with one another. So when you post your status, that actually needs to tell the timeline in some way that it needs to update so that your status gets added into it. And likewise, the filters on the side do the same thing. They say, hey, timeline, I'm now filtering on X. Please refresh yourself. And all of these on the right actually do the same thing. The search and the trending topics, all of them interact with the timeline. And so if you were to imagine what this would look like with most people writing it, it usually ends up looking something like this. So you have 3 different objects, but they all kind of know about each other. So you have the timeline filter, which is referencing the timeline. You have the status poster, which is referencing the timeline. And then you have the timeline that's just sitting there minding its own business. So that's what we call tight coupling. Right? An object knows about another object explicitly. And this is where people say, well, can't you use events for that? Like, events work really well. And the observer pattern is actually really good when it's okay for 2 objects to know about each other. Right? So you get a reference to a button on a page, and then you say, on click, do something. But you had to know that that button existed, and you had to have direct access to that button in the first place in order to do it. That creates a tight coupling. So what you actually want to do is use a pattern that's called the mediator pattern. How many people have heard of the mediator pattern? Just out of curiosity. Oh, okay. A few people. Excellent. It's the little-known, less popular cousin of the observer pattern. And the mediator pattern basically says that each of these objects only knows about the mediator, and then the mediator tells each of them when a message comes in that they're interested in. So in this example, the sandbox is acting like a mediator. So both modules know about the sandbox, which is cool. In the timeline filter, when the filter changes, I call this sandbox.notify method, which is just basically saying, here's a new message. The timeline filter has changed, and here's the filter that it was changed to. Right? This has no idea if anybody is listening for that message at all. Just sending it out there into the ether, just in case anybody wants to know, timeline filter has changed. Well, cool. And same with the status poster. That's also going to notify that there is a new status. It's not telling the timeline directly about this. It's just saying, hey, if anybody out there is interested, there is a new status that was available. Here it is. Do with it as you please. So that's loose coupling. Right? It doesn't know about the timeline itself. So in the timeline, it basically uses a sandbox and says, I want to listen for these specific messages. And when these messages occur, please call this function. And so now the timeline also doesn't need to know about any of those other modules. It just knows that at some point in time, I may receive these messages. And when I do, I should definitely do something in response to them. So that each of these modules can exist on a page by itself now, right? Because the status poster and the timeline filter could actually be out there on its own and just saying, hey, filter changed, and nobody's listening to it. So it doesn't really matter. But it doesn't break anything. It's not dependent on something being there to respond to that message. Timeline is the same, right? It's listening for a bunch of messages, but if those messages never arrive, then no harm, no foul. It's just going to sit there doing its job as normal. It's loose coupling. And when modules are loosely coupled, that means you can just remove a module from the page and it will continue to work. So if old Twitter were built this way, you should have been able to remove the timeline completely from the page and still interact with everything and get no JavaScript errors and need no changes to any JavaScript code. That's the benefit of this. The application core also handles errors. And this is really important as you're going through because you don't want to have a bunch of one-off error handling in your code. And this is a horrifically ugly pattern that I'm not actually going to go too deeply into. But what this basically does is for a module, it takes in the modules and then wraps each of their methods in a try-catch and then reports an error if that occurs. And so you can have that on in production and off when you're debugging on your dev box so that the errors actually pop up right in your face. I'm not going to go too much into it, basically because I did an entire talk about this before. So if you're interested in learning a little bit more about that, please stop by my SlideShare account, which is just slideshare.net/nzakas, and look for this enterprise JavaScript error handling presentation. So what does the application core do? Manages the module lifecycle, enable intermodule communication through the mediator pattern, general error handling, and it also must be extensible. So why extensible? Well, because your web application is going to change. Right? The worst thing that you can do is build up an application framework based on what your web app is today. Right? That will get you to where you need to be today, and then next year when it changes, you'll find that you're really boxed in and you can't make changes without rewriting a whole bunch of stuff. So plan for extension. I thought one of the most brilliant pieces of the digital photography era was when Canon came out with their digital SLRs, and all of the old lenses for the traditional film cameras worked. Brilliant. That means I don't need to go and buy all new lenses for this thing that essentially does the same thing. It's just on the inside that it's different. And cameras are really good at that. Cameras are built for extension from day one. You want to be able to swap out lenses. You want to be able to swap out flashes. You want to be able to change any number of things. And so you should think about your application framework in the same way. You want to plan for extension. Figure out where you think things might change and allow an interface for them to change. So where might things change here? Well, alongside the application core, you may actually want to add more functionality as you go along. So you start out with the basics, the stuff that we just talked about, but you might want to add some more. So what might you want to add? Well, you might want to add different types of error handling. Maybe the type that you had initially doesn't quite work. AJAX communication is a big one, which we'll talk a little bit more about. New module capabilities. Maybe you decided that, hey, I want to create a new piece of functionality in the universe that all modules should have access to, and you just plug that into the application core and keep going. And then any sort of general utilities that you could think about, XML parsing, JSON parsing, whatever. Pretty much anything. The idea is that you start out the application core just doing the smallest number of things that it needs to do, and then allow for extension. So AJAX is my favorite one. And that's because it comes in a bunch of different flavors. And this is something that tends to change over time relatively frequently. So there's 3 parts that have to be in sync for AJAX to work. One is the request format, so what you're actually sending to the server. 2 is the entry point on the server, what's receiving that data. And then 3rd is the response format. So what's it coming back as? XML, JSON, some custom text format. So you want to have an extension for this from the start, because guaranteed it will change. So if you take a look at this, very simple, back in the early days of SOAP and such, you'd have a request going out to the server, maybe some query strings. The server has an entry point called AJAX, and then it gets back an XML document as a result. And so then you have a basic implementation of reading that with just an XML HTTP request, and it's a complete mess, right? There's a lot of stuff that's going on in there. And you see all of the aspects of AJAX communication are in there. Right? So there's the entry point, /AJAX, the request format right after it, and then the response format. So it actually has to parse the XML to get the data that it wants out, right? Which is kind of crappy because if any of those change, that means you have to go back into your code and change it. Implementation using a library, people say, is a little bit better because it abstracts a little bit, but you still end up with the entry point and the request format and then the response format. Right? All of that stuff that you still need to deal with, And then on top of it, you have a reference to the library, which also makes it a little bit more tightly coupled to the library than you probably want. So what you want to go for is something like this. And so use the sandbox, and you create a request. Now, requests are always name-value pairs. And that's what you're sending to the server. Right? This is equal to this is equal to this, do something with it. And then when you get it back, all you really want is a fast way to get to the data that was sent back to you. And if the data is always being sent back as XML, why can't somebody do that for you ahead of time? So that's what the AJAX extension does, right, is it abstracts away all of these. It knows the entry point to send to. It knows how to format your key values to send to the server. And it knows how to parse the data that's coming back and then pass it back to you in a format where you can just start pulling data out. So encapsulating all three of these is very key, because I can tell you from experience they change very frequently. So when you decide that you want to go and change your entry point and then change your response format, all of those modules that are making AJAX requests do not need to change. You just need to change that extension, and that's it. Everything continues to work. So the AJAX extension jobs, again, just to review, hide AJAX communication details, make sure that those three pieces, the entry point, the request format, and the response format are all taken care of. Provide a common request interface so that you don't ever need to worry about, oh, I'm using YUI, or I'm using jQuery, or I'm using XML HTTP request. It should just be one API to do that. Provide a common response interface, so the extension should take the response, parse it into some usable format, and then pass that on. You should never be passing the raw response on into the module. And manage server failures. So this is actually a big one that is a huge pain when you first get started, because there are a number of things that can go wrong with an AJAX response other than getting like a 404 or a 500. Right? Because you could get a 200, but you might actually have a broken response in there. It might not be parsable. And so your AJAX extension should be able to parse that and say, oh, wow, this is actually not what I expected at all. I'm just going to call the failure callback for that. Likewise, your server may actually send back a 200, but the body of the response might indicate that there's an error. Now, I've dealt with all of these, and just having a way to abstract all of that away was great, because the module doesn't really care why it didn't get the data that it wanted. It only cares that it didn't get the data. Okay, so the last thing we're going to talk about is the base library. So the base library all the way at the bottom just provides your basic functionality. And this is your YUI, your jQuery, Mutuals, prototype, whatever you happen to like. That's where it lives in the architecture stack. Most applications that are out there are actually way too tightly coupled to the base library. And this is very scary, especially if you're on a small team that's just starting up, is a lot of times you end up so tied to the library that if it doesn't work for you, you actually are stuck, because the amount of time it would take to undo all of that work and redo it in another library is massive, not to mention just the training time and getting up to speed. And nobody likes needing to rewrite from scratch. So it's really great when you can abstract that base library out as much as possible. So there was actually a talk at OSCON in 2007 by Joseph Smar that was called High Performance JavaScript. No relation to my book, by the way. But he had this really interesting theory about JavaScript libraries. It was basically you should use it like scaffolding. Is you use it to get your application up and running quickly, figuring out what parts that you need, and then start to replace the parts of the library with more specific code that works for you. And the reason for that, again, is to make sure that you're not tying yourself to the future of some library. Like, you don't know that a library is going to be around tomorrow. We like to think that they will be, but you never know. Or the library might change in some way that makes it difficult for you to continue upgrading. Using a JavaScript library as scaffolding is a fabulous idea. And this was his talk. You can check it out on josephsmar.com. Very good talk in general. So ideally, only the application core has any idea what base library is being used. I say ideally because I don't want people to come after me and like hunt me down after this, as they tend to do when I give this talk. If you want to build your application on Dojo and you feel like it's okay that everything in your application uses Dojo and you want to bank on that for the next 5 years or so, I will not stand in your way. However, if you do abstract that out as much as possible, that means at some point later you could swap out to YUI and everything would just continue to work. Because basically you would rewire the application core only to use YUI, and then everything else in the stack continues to work. And the big point about this architecture is to make sure that you don't need to make changes to modules whenever a larger architecture change has to be made. So the base library jobs are browser normalization. So that really is the only layer that should know which browser is being used. General purpose utilities, of course, all your parsers and serializers and object stuff and DOM stuff, all of that stuff. And also provide low-level extensibility, right? As you want to be able to extend the base library as well as the application core. And where you want to extend depends on what you're trying to do. If you need to do something that needs to know about the browser being used, then that should be a base library extension. If you need to do something that extends what the application as a whole can do, that's an application core extension. So as a little bit of a wrap-up, we just want to talk about the knowledge that exists within this architecture. And so the base library is the only part that knows which browser is being used. Right? Any place else in the architecture, you don't want to have is IE or is Firefox or anything like that. That is the job of the JavaScript library, is so that you don't need to do that anymore. The application core is the only thing that knows which base library is being used because it's using those APIs directly. And so if you change the base library, then you also need to change the application core, and that's okay because you're still limiting your changes to one area. The sandbox only knows about the application core because it has to call directly into it. And the sandbox doesn't have any functionality on its own. All it does is pass through to the application core. And then the modules don't know anything except that the sandbox exists. They don't know about each other, and they don't know about the rest of the architecture. Only that the sandbox exists and that they can use it. And no part knows about the web application. Again, these are all just puzzle pieces, and the web application is what's created when all of the pieces come together. So the advantages of this are that you can actually create multiple different applications using the same framework. You can pick this up from one app and drop it into another, and stuff works. You can also, at any point in time, create a quote, brand new web application just by changing the modules that are on the page, right? Remove some, add some new ones, and you more or less have a new web application. Each part can be tested separately, and this is really huge. This is where loose coupling is really your friend, is that you can write tests to test an individual module. You can write tests to test just the sandbox. You can write tests that test just the application core, and actually build up this great suite of tests that allow you to know that things are still working the way that you want. And that's because everything is just being built to an interface. And interfaces can very easily be stubbed out for testing purposes. And lastly, the entire point of this is kind of like Jenga, is you want to be able to pull out a block at any point in time and not have the entire tower collapse. And if you follow the patterns that are in this, I think that you can get there. So that is what I had to say. Not bad. That was awesome. I ended with 30 seconds left on my countdown clock. That's good timing, right? And if you'd like to get in touch with me, there's various ways. My blog, my Twitter, SlideShare. These slides are up there. You can go and grab them now, if you so please. That is it. Everybody is mesmerized. Yeah, go ahead. Okay, so the question was, what sort of pain points have I encountered while using an architecture like this? Well, I think the biggest pain point is building too much up front. So the first time that I did this, we actually had a bunch of built-in assumptions about what the application was going to have to do. And we spent a lot of time figuring out those like really complicated problems and implementing solutions for them. And then when we got there, they're like, oh yeah, application doesn't actually have to do that. And so we were left with a bunch of patterns and sort of a bunch of cruft that we never actually needed to use. But we also didn't have time to go back and just pull out because it was so intertwined with the core. And that was where, if we had started out and just made the core as simple as possible, where it was just managing the module lifecycle to start, and then built everything else as extensions, we would have been much better off. Which is why now I say that's definitely what you should do. You want to make each piece just as small as possible to begin, because that way you have easy ways to start pulling things out if they're not working. And yeah, developers, getting upset about not touching the base library directly was also a huge thing. Cool. Any other questions? You can also feel free to grab me outside after this. I know I'm standing between you and lunch, and that's not a great place to be. But I will be around for the next couple days, so feel free to pull me aside or shoot me an email or whatever.